Okay, in this video I'm going to do an example of a loss budgeting problem where we first work in dBm units, and then it asks us to convert everything into milliwatts and picowatts. And the idea here is that I have in a decibel unit scale, this is sort of a vertical number line, P in and P out, which is less than P in due to the loss L of the communications channel, which has a loss of 90 dB in this case. And everything has units of dB so far, and I'm going to write that P out is P in minus the loss. And this is all in dB units. Okay. And I'm given the loss. Loss is 90 dB, typical for a wireless channel. P in is 23 dBm plus 23 dBm. And we're asked to calculate the output power. So I can just plug directly into this equation. 23 minus 90 is minus 67 dBm. Let's see, double check. 67 plus 23 is 80 plus 10 or 90. Okay. And so that's how easy it is to do loss budgeting problems. You're given 2 out of the 3 variables and you solve for the unknown, P out, and you're done. Very simple calculations typically. When you have to deal with milliwatts, it's a little bit of a pain. We're going to convert from dB to linear units, and so P in milliwatts is 10 raised to the P in dB over 10. And this is 10 raised to the input power is 23 tenths, and this is 10 to the 2.3. On the calculator, this is going to yield, I know from the rule of tens and threes that 23 dBm is 200 milliwatts. Let's see if that comes out here. 10 raised to the 2.3 power. 199.5. So I'm going to write 200 milliwatts. My calculator gave me 1.99 times 10 to the 2. So that's 199.5. I'm going to call it 200 milliwatts. The output power, P out in milliwatts, is 10 raised to the P out dBm over 10, or 10 to the minus 67 tenths, or 10 to the minus 6.7, which is 10 raised to the minus 6.7, and that is 1.99 times 10 to the minus 7. Let's call that 2e minus 7 milliwatts. Wow, that's a lot of loss. 90 dB of loss means that only 1 part in a billion comes out. 10 to the 9th is a billion, and so the loss ratio is 1 times 10 to the minus 9th. And that's why when we start with 200, we end up with 2 times 10 to the minus 7th. Okay, this is, let's see, oh, okay, here it asks us to convert it into picowatt units. It's 2 times 10 to the minus 4th, from milli down to micro. So I've added 3 to the exponent and changed milli to micro. And now if I change micro to pico, I add 3 again, and it's 2 times 10 to the minus 1, nano watts, from micro to nano, and then subtract 3 again to get to pico, and I get I add 3 again to the exponent. I went from minus 7 to minus 4 to minus 1, and then up to plus 2 picowatts, or 200 picowatts coming through. And believe it or not, a lot of wireless systems can deal with such tiny powers due to large typical losses of the wireless air channel. Okay, hope this video helps on this one, and thanks for listening.